Hi and welcome. I hope everyone is okay. Now, in this lesson, we will go on where we stayed in the last lesson. So, as you remember, we were solving an example about the expected value of and the variance value according to according to linear combinations uh, each values. So we have the x and y values and the probability of x and the probability of y, and then in the last lesson we had solved the a question, and we had found the expected value of x plus y, the variance value of x plus y. And then the other section, B question, draw a probability distribution table for the random variable t. T means x minus y. Find the expected of t and variance of t. Okay, now we have sum table, and 2 minus 0 2, 3 minus 0 3, and 5 1 2 and 4. And then if we want to work out the probability of x minus y, so 2 and 0. I want to look at the other monitor for the probability of value. Okay, and then 0 and 2, 2, the probability of 2 means 0.6, and the probability of 0 0.2, and it means 0.12. And the probability of 3 and 0, 0.18. The probability of 5 and 0, the probability of 5, 0.6. The probability of 0, 0.5. It means 0.3. And the probability of 2 and 1, 0.08. The probability of 3 and 1, 0.12. And the probability of 5 and 1, 0.2. And t means x minus y. And we can get the 1, 2 minus 1, 2 minus 1. So it means 2 and 1, the probability of 2 and 1, 0. Excuse me, 0.08. And if we want to get 2, we can get both 2 minus 0 and 3 minus 1. So 2 minus 0 probability is 0.12. 3 minus 1 probabilities 0.12, and we should add, and we can get 0.24. And the probability of 3, we can get 5. We can get 3 minus 0, so it means 0.18. If we want to get 4, 5 minus 1, so it means the probability of 5 and 1, 0.2. If we want to get 5, it means 5 minus 0, the probability of 5 and 0, 0.05. 0.3. Okay, now according to these values, if we want to work out the expectation OT 3.4, the variance OT 1.8. And then our question OC, the expected X 3.8, the variance X 1.56, and the expected OY 0.4, the expected OY 0.24. Comment on your results for expectation and variance of the sum and difference of two independent random variables. Okay, now they gave us the expected value x and the expected value y, and also for variance. The S means x plus y, as you remember, and the expected value x they gave us 3.8. The expected value of y 0.4, and we could find the expected value as means x plus y. So the expected value s, the expected value x plus y, and it means 4.2. 4.2 means 3.8 plus 0.4, and 3.8 means the expected value x, 0.4 means the expected value y. So the expected value x plus y means the expected OX plus the expected OY. Okay, now for variance, the variance of x and the variance of y, I want to look at the variance of x and the variance of y. One of both 1.56, 0.24, 1.56, 0.24, 1.56, 0.24, and we could find the value, the variance of x plus y means 1.8, 1.8. So the variance of s means the variance of x plus y. It means 1.8. 1.8, if you notice that, means 1.56 plus 0.24. 1.56 means the variance of x. 0.24 means the variance of y. It means at the end of the means, the variance of s, the variance of x plus y means the variance of x plus the variance of y. Okay, now if we want to add two or more randomly variables, and if we want to find the expectation, we should add both expectation. If we want to find the variance of two randomly variables, adding the two randomly variables, we should add the variance of random variables. And let's look at the x minus y. and I want to write again their expected value and their variance value. Okay, and now the expected value of t means the expected value x minus y. It means 3.4, and 3.4 means 3.8 minus 0.4. So this is the expected of x, this is the expected of y, and we can receive the result. The expected value of x minus y means the expected value of x minus the expected value of y. But please notice that for finding the variance value, our variance value for each, I want to copy paste. Our variance value for each, excuse me, yes, yes, and the variance value of t, yes, and t means x minus y, and it means 1.8, but 1.8 means 1.56 plus, don't minus, isn't minus, plus 0.24. So this situation shows us the variance of x minus y means the variance of x plus the variance of y. Okay, why the variance of x minus y means the variance of x plus the variance of y? Why change the sign? Why change the sign according to other situation? Because please remember that if you want to linear combination, the variance linear combination of variance value, for example, the variance of ax plus by. In the last lesson, we had learned this situation means a square multiply the variance of x plus b square multiply the variance of y. And in this question, we have the variance of x minus y, and this process I can write the differently for this process. So the variance of x plus -1 multiply y, according to before process, and I can write the variance of x plus -1 square multiply the variance of y. So it becomes the variance of x plus the variance of y. Okay, now please notice that if you have subtraction, all exactly for expectation process doesn't change. The expected value x minus y means the expected of x minus the expected y. But on the variance working out, exactly minus exactly change, minus change to positive. Okay. And I want to some practice about this situation, for understanding very well, for you for understanding very well. For example, we have the variance of 2x minus 3y. So you should write 2 square the variance of x plus minus 3 square the variance of y. It means 4 the variance of x plus 9 the variance of y. Okay. But if you want to work out the expectation, doesn't change. For example, the expected value of 2x minus 3y, it means 2 multiply the expected of x minus 3 multiply the expected of y. Okay. Now, and the C section on our question. Okay, now we commented on our results for expectation and variance, or the sum difference of two independent random variables. And now our result, when independent random variables are combined, their variance are always added. Note that this example shows that to find the difference of independent random variables, we find the difference in expectation, but at the variance. Okay. Now we have one more example. The random variable x, you know, this is binomial distribution, approximation to the binomial distribution. So n value 12 and nu, or the expectation of x, is 0.2 for x. And for this, n is equals to 2, nu, or the expectation of y, is 0.8 for y. And the random variable w equals to x minus y. Work out the expectation and variance of w. So if we want to the expected value of y, means the expected of x minus y, it means the expected of x minus the expected of y, it means the expected of x, excuse me, I have one mistake, because the second value, as you remember, for p. So for x, nu means n multiply p, and it means 12 multiply 0.2 and 2.4, and y nu n multiply p, so it means 2 multiply 0.8 and 1.6. And for variance, as you remember in the binomial distribution, variance is sigma square. It means m multiply p multiply q. Q means 1 minus pi p. So for x our variance for x our variance 12 multiplies 0.2 multiplies 0.8 12 multiplies 0.2 multiplies 0.8. So I want to look at the results for the variance on the other monitor. Okay. On the other monitor, I look at the variance about the this binomial distribution, and it means is 1.92, and for y, the variance of y, m multiply p multiply q, it means 2 multiply 0.8 multiply 0.2, and it means 0.32. Okay, 32. And this is the expectation of x means nu, and it means 2.4 minus 1.6, it means 0.8. The value of w, it means the value the variance of x minus y. Please don't forget it means the variance of x plus minus -1 square multiply the variance of y. So it means the variance of x we could find 1.19 1.92 plus the variance of y 0.32 0.32, it means 2.24. Okay, now when is 2x unequal to 2x plus x? The following red and blue dices as a fair six-sided have been given. Let the random variables x and q be the scores obtained when the die is rolled. For example, red six-sided dice numbered 1, 1, 2, 2, 2, 4. We can work out red dices x, the expected of x, 2, the variance 1. For blue dice numbered 2, 2, 4, 4, 4, 4, 6, 8. So we can work out the expected value 4, the variance value also 4. And I want you to notice that the red dice numbered or x value 1, 1, 2, 2, 2, 2, 4, and then the blue dice the q 2, 2, 4, 4, 4, 6. And if you notice that on the blue one, all number equals to double red numbers. Doubled red numbers 1, 2, 1, 2, 2, 4, 2, 4, 2, 4, and 4, 8. Okay, it means q equals to 2x. But if we want to the expected value of q, it means the expected value 2x or 2x, and it means 2 multiply the expected of x. it means 2 multiply 2 and 4, and it also occurs to this situation. But for variance, all the process change. For variance, for all process change. For example, if you want to the variance of q, it means the variance of 2x, and it means 2 square multiply the variance of x, and it means 4 multiply 1 and 4. So for q, the variance value is 4. But if I want to 2x, write differently, 2x means x plus x. So the variance of x plus x, the variance of x plus the variance of x. So 1, the variance of x 1 plus 1, it means 2. So this situation is very different. So for the variance value 2x unequal x plus x. But please don't forget, for the expectation doesn't change. But for the variance value 2x doesn't 2x isn't the same x plus x. Okay, now what would happen if we rolled red dice twice and added the scores? Because in this situation we say that x1 and x2 are two independent outcomes from rolling red dice twice, and we write x1 x2. So x1 x2 for the table values, and the probability of x1 and x2, these values. If we want to work out the expectation for, but if we want to work out the variance 2, so it isn't the same. The variance of 2x, so it isn't the same 2 square multiply the variance of x. We don't get the outcomes of doubling the score. This is not the same as 2x from the blue roll of the dice. We find if we want to work out the expectation, okay, the same. But if we want to work out the variance, the variance of x plus x unequal the variance of 2x, because this is the variance of x plus the variance of x. This is 2 square the variance of x. Okay, now please notice that in the question, some question, you will look at some keyword. For example, if they say two randomly choosing something separately, so okay, now we should find x plus x. We should find the expected of x plus the expected of x. We should write x plus x or x plus x value. It means the x value, x variance plus x variance. But if they say 2 times of the something that is random variable two times differently x plus x. So okay, the expectation of 2x doesn't change. It means 2 multiply the expectation of the expected value of x, but the variance every time change. So the variance of 2x we should write, and we should write 2 square multiply the variance of x, and it means 4 multiply the variance of x. Okay. Okay, now in this lesson we could finish, and the other lesson see you soon.